Okay guys, today I'm going to teach you how to do everything relating to a theme in Etterna. Yeah, so first thing you're really going to want here is you're going to want the game. And to do that, you're going to want to go to GitHub and get the game. Actually, you don't want the release, you don't want an installer. It'll be really helpful if you got the source of the game. You can survive without it, but honestly, I wouldn't. I would not do that to you. You definitely would not survive without it. You're not gonna. There's no documentation. I'm gonna be real straight with you. It's not helpful. So, well, there is documentation. Actually, I'm literally lying. So here, I don't know. You can't see that at the top, but at docs.etterna.dev, you've got our documentation. The problem here is that only complete documentation is on the C++. And we have Lua documentation. It looks like this. I mean, that looks pretty comprehensive, actually. It shows you all of the class types you can use in Lua. But the problem is, you go into one of them, say for example, the screen, there's nothing. So, you're on your own. But, besides that, I'm just going to teach you everything here, so you don't need the documentation. You do want the source. When you have the source, you want to unpack it into a folder, such as the folder you're looking at. It's going to have a bunch of garbage in it. That's okay. You can actually put your game save in this folder. You can merge your installation with the source. Say like what you could do is you take an installed version of the game and you combine the downloaded source from GitHub into this folder. Don't replace any files. If you replace files, you break it. And if you complain about that, I'll find you. Now we're gonna get set up in the IDE, and by IDE I mean text editor. This is Visual Studio Code, vscode. There's not much more to it. Actually, there's one little bit of setup you want to do here. We have an extension actually called @Lua for vscode. Get this. If you don't have this, you will not succeed. And you also want a basic linter for Lua, vscode Lua. If you don't have both of these, then you will not have a good time. Now, I will begin to explain what goes in a theme. Before we even get to that point, we have... Actually, yeah, we'll just go with the theme folder. So, here's my themes folder. It's got a lot of folders in it. And we're going to start with the fallback folder. Yep, looks good. Alright, we're going to go to the till death folder. So the way this works is essentially the organization is bganimations contains all of the screen definitions in Lua. At least as far as you need in terms of screen definitions. Metrics.ini drives the whole process. So, say we have in the metrics.ini for the till death theme, we have a global fallback theme that points at fallback. So, I'll talk about why that works in a minute, but the resolution of the till death theme is 480p. And then there's a whole lot of other stuff that we don't really care about right now. But to put it shortly, the way that these individual things work is you can define a screen here. I did this in a different video, by the way. And then you can specify the type of C++ class it is. And how it works in terms of what happens when you press the escape button, what happens if you press the enter button. And then this type of stuff is like specific to the screen. So like you wouldn't see this if it's not an option screen. Let me find an example. Like this is a text entry screen. This is select music, and so on. So, and there's metrics can actually have anything you want in it. So, for example, these are metrics definitions for random actors. This is the music wheel that is in the room select screen. So this is the room wheel, and then this is the items on that wheel, and this is the info that goes on those wheel items. That's just a random fact. There's nothing you need to care about with that, because I might actually remove that in this version. Anyways, let me talk about how this gets here. So you may notice that we're in the tilde theme, and we're on the, what do you even call this? You don't know what to call this. I know what to call this. So in the F3 menu, in the F6 page, it shows the name of the current screen right there. We're in the screen title menu. Now, how is the screen title menu defined? Let's find it. Well, it doesn't look like tilde defines anything really useful to us that tells us about what it actually is. So, since we have a fallback theme, tilde points at the fallback theme, then we need to go to the fallback theme and look at the metrics in the fallback theme. And we find title menu here. It looks like the theme title menu is defined as a screen title menu in C++. And let me go back to that documentation. The reason the documentation might be useful to you is the list of actual screens that you can put in this right here is right here. Oh, right here. That's pretty much it. This fallback line means that if you make a screen that is like a sub, it's supposed to inherit its features of another screen, you would point it back at something else that exists. So the ScreenSelectMaster, it can also be another one of these things, or it can be something that you defined here. So I could actually put screen init or screen splash here. Okay, so that's what this screen is. Now, how does everything get on this screen? Well, the answer to that question is not always the same, but for the most part, a lot of it can be answered by what do you find in the bganimations folder of the theme you have loaded. In this case, the title menu, you can find what's on the screen by simply looking for screen title menu, overlay, underlay, or decorations. And decorations is not present here because we don't want to go that complicated. Every screen type has an underlay. Not all screen types have an overlay and decorations layer. So that's why we tend to put a lot of things on the underlay, because you can't really go wrong. The difference between underlay, overlay, and decorations and background, and there's probably one other one, is really just the layers that they end up on. The names of them should be obvious. Underlay is the lowest. Background can go in front of that, I think. Decorations is in the middle, and overlay is on the top. So, how do these things get on the screen? Well, let's actually look at how this works. So, we'll just actually look at the entire Lua setup for the screen title menu. Here's the overlay to the screen title menu. Obviously, this means nothing. It looks like what we're doing is we're setting up a frame that holds a bunch of things, and then we are attempting to load two actors onto it. And that's it. Now, you can't... What I'm going to tell you just straight up is that none of these things are visible right now. Unless I click. And if you see me clicking, you can see the little thing that goes whoop, or whatever you want to say, describe this action. Well, that's something that this is doing. So, how did the rest get here? We'll go to the underlay. And here's where we get into some meat. So, I'll just start going through this stuff. Basically, the way this works is you have we're defining another actor frame. Every one of these Lua files has to return an actor frame, by the way. So it's really easy to just define it at the top of the file. Local T def actor frame empty. And then at the bottom of the file, return T. By the way, if you don't know how Lua works, that's tough. Go find out how to do that first. Yeah. Luckily, we've commented some things. Very rare to see these things here, but the rectangles you see on the screen, the up-down stripes, that's going to be... actually, let me even show you the full details here. What this rectangle actually points at, and what these lines are, it's talking about the rectangle that you see on the left side right here, and the rectangle over here, and then the vertical lines. So if I change the colors to something else, like this, saved it, and then reloaded the screen. Don't press restart on screens unless you know what you're doing. Then it looks like that. Alright, so this is something that I do to just see the background. So next thing we have here is how did this text get here on the left is there's more of this stuff here. I'll explain these types of things in a bit. And there's a little bit more. So we've got this big thing is for this button. This here is for this name. This is here for this. Oh, clicking it actually opens up the GitHub. And then there's this, which is, it's an invisible button, actually. I don't know if anybody's ever seen this, because we update like once every 25 years, but basically, it looks like this. It takes a minute to load sometimes. There it is. And when you click this, it just opens up the GitHub, basically. That's all. And down here, we have something kind of weird. It's defining a bunch of buttons in weird places. But if you take about 5 seconds to actually read what's going on here, you can see that this has something to do with scrolling and choices and things that are on the title menu, and perhaps something to do with clicking. So, if you haven't figured it out yet, you might want to go back to elementary school. This has to do with adding clickability to the scrolling options here. So if I left click there, I end up in this screen. Okay, and just for your entertainment, I'm going to click this button. And that's what all this extra code here does, is it starts music. So maybe if you didn't know there was a jukebox on the home screen of the Till Death theme, there is. And you can right click to stop. Okay, so that's the title menu. I hope that explained everything, and now you know how to make a theme. I know it didn't explain anything at all, actually. So let's just go into Select Music. We'll skip this screen. Actually, just don't even acknowledge this screen exists. This sucks really bad. If you ever have to make a Select Profile screen, just copy it from Till Death, honestly, and then fix the Lua errors. Oh, you know what I didn't tell you is what's really important is that anytime you're doing anything at all in Lua with this game or messing with metrics, you want to have 8 on the F3, F6 menu turned on. And what this does is, let me go back to the title menu. And I will put some garbage in here. That's not going to load, so if I reload it, we get a little error at the top of the screen. And also the background didn't load at all. And nothing is clickable, but things just kind of work out because that's how things are. But the important part is you need to know how to get the information that's telling you things are broken. And to do that, you have to have this 8 turned on, and to hold it at the top of the screen, you can press 9 here, and it will hold it at the top of the screen. So what this means, if you want me to try to translate it, I mean, this is basically in English, so if you can't read that, I don't know what to tell you, bro. You look in the Themes folder, bganimations, screen underlay, line 40, it's saying there's something weird going on near here. Line 40, that looks perfectly fine, but if you have half a brain, you look above it, and yeah, it looks like we didn't do something right here. Okay, so we fixed the problem, and there it is. These Lua errors can look way different, so if you do something like this, then, hold on a second. Okay, then maybe your error starts to get a little bit longer. And now this is pointing at a different problem, saying that I'd attempted to compare a number with nil, and it's on line 38. Sometimes these errors get really long. Really, it's like a stack trace, if you know what that means. If you don't know what that means, it's like when a function calls another function and then it keeps going down into a little bunch of extra calls way down. This is saying on line 38, in some unknown context, we're hitting something that says I attempted to compare a number with null. And on line 38, you can see here that I have A, which is apparently defined as nil, being compared with a number. That's not allowed in Lua. It doesn't let you do that. Okay. So that's a little bit of debugging knowledge for you. One other thing that you really want to turn on is you go into your preferences with the game closed. Don't do it with the game open. You want to scroll down here and turn this on. ShowLogOutput equals 1. This will put this on your screen. And this is really important if you want any amount of knowledge on what is going on in real time. For example, if you don't know what's happening in what order, then here's what you can do. Here we've written an init command and an on command and an actor. And I don't know what order they occur in. It's almost always a consistent order, by the way. We don't know what order they happen in. At least you don't. I do. What you can do is a lot of things, actually. But the simplest I do is ms.ok. What this does is it shows a message on the screen and prints on the console. If you're really weird, you can type print instead. Actually, I wouldn't even recommend doing this. I would recommend always, actually, just doing ms.ok. And the reason why is because this function accepts any type and will not throw an error. So if you put a table in this, it'll be okay. If you put a string in this, a number, or like garbage, it'll be okay. And if you throw like nil in here, it'll be okay as well. That's pretty much it. So what you do is when you don't, it's basically really hard to get a stack trace in Lua without actually throwing an error. So, and you don't want to throw an error like 99% of the time. So basically what you do with debugging is this happened first, it's 1 probably, or we want to know when does 1 show up, when does 2 show up. So we save that, and then we just reload the screen. Oh, well, it says 2 there. We didn't see 1. That was kind of useless to us, but we have the logs. So really what this is it's a real-time log output. So if I go into the log folder of the game, and I pick the newest log file, and I go down here, it'll look the same. But anyways, what we're looking for is when did 1 show up, and when did 2 show up. So we know that it's pretty likely that init command happens first and on command happens next. So there you go. And you would use, I mean, I'm just showing you how I'm using an example of a scenario in which you would want to do that, but you would print things to the console under pretty much any context. I mean, there's a million different reasons why you would log things to the console, but for debugging purposes or for informational things. So yeah. So let me go back and get rid of that. Okay. So now you know how this screen works really vaguely. Let me tell you one more thing. So how do these specific choice names get here if I didn't tell you anything about what actually these buttons mean or what defines them? So that's a good question. Here we are in the metrics.ini of TildeDeath and under the screen title menu. Now, the way the screen title menu specifically is defined is this doesn't work for every screen. It only works for options screens and the title menu or things with a choice controller basically. Is you have to define a choice names line in the metrics and then give a comma separated string. And what each of these things in the string points at is a particular item that is also defined in metrics under a screen title menu. Now you see game start, multi, options, pack downloader, AV, color, GitHub, report bug, exit. Not all of those are here. Exit and game start are not here. Well, use your brain. We're falling back on the fallback theme, so we have to look at the fallback metrics. And you look in it, and we see here, here's a fallback choice names. We don't use that because we've overridden it in the TildeDeath theme. But here is the game start definition. And here is the options definition. And here is the exit definition. There you go. Now, each of these little lines here, that's not the choice names line, it looks kind of nonsense. I mean, if you kind of like just look at it for a second, it makes sense. It's not like that hard to understand, but what you can call this is a game command. and it's really complicated to actually know everything about how a game command works. But at the basic level, the syntax is function name, comma, parameter, semicolon, next function name, comma, parameter, so on. You can have infinite commas, you can have infinite semicolons. So if you wanted a function with multiple parameters, you have function name, parameter 1, comma, parameter 2. And you can just keep adding a bunch of these repeatedly over and over with a bunch of semicolons. So I can just pretty much tell you, I think if you look at this for like 2 seconds, you already know what's happening, but let me just tell you exactly, just so you're not guessing. The game start button says apply default options. Immediately, that actually doesn't make any sense. So this is a game command specific function where it applies default options. Yeah, that makes no sense, but I'll tell you how we figure out about what that actually means in a second. So next function we have is text game start. And what does that mean? Well, that means in game command speak is look inside the theme language file for a text under the current screen named game start. Is that true? Well, it might be. So we look in the language files for till death. This is in the languages folder. en.ini is the default in the fallback for the theme, and you can have other languages here too. And it looks very familiar to you if you know how the metrics looks, or the ini file format, honestly. This is a section, and this is a line definition. So we're looking for the title menu. And here we are. Everything in the title menu is strings. Engage, well, that's kind of useless. This is basically how you would translate to different languages, or you would rename strings. But we're not finding what we're looking for here, so I guess we'll have to go to the fallback theme. Here is the fallback ini, ini. And it looks like we can have a lot of different things. We even had a chat.irc string here. What? Thank you, StepMania5. Alright, so here's game start. Game start is pointing at specifically this, and it's going to return the value found here and output it right there. And that's how strings get in the game. Okay, and then the next thing we have here is screen, comma, and then there is something that looks a little weird here. What screen is it's another game command function that will set your current screen to the parameter. And this is actually the parameter right here. So what does this even mean? This is a Lua string concatenation. So we're terminating the first string, we're concatenating another string, and we're calling a function to return another string. And yeah, you can actually call functions in the metrics lines that are written in Lua. If we wanted to find this function, here it is. And then it points at another function. And eventually we get ScreenSelectProfile, ScreenSelectStyle, ScreenProfile load. And that's why when you hit enter here, you end up here. Or if you have no profiles, you end up in a different place. So that's how it is. I will get into how all this stuff works later. Maybe. Now we'll look into, I mean, here's a case where you got a choice definition that's just going to point you straight at a screen, no other possibilities. This is what it would normally look like. So after this screen concatenation has been resolved, it looks something like this. And you can put these things in any order, but they're executed left to right. So preferably have them in a particular order. Here's another thing that's got like which edit menu do you go to, and this one closes the game. Screen exit actually closes the game. To be honest, that's about as straightforward as you can get. And we have another function here called urlnoexit that will actually open your browser to the given parameter. And that's how that works. Okay. Now, one thing I want to get into next is how in the world do you find out how anything works if you have no idea? So, first of all, try things until you figure out and understand. And another thing is, I'll use this as an example. What even does apply default options do? Well, I hope you know C++. So, here's the reason why I wanted you to download the source. So, when you have the theme and the source and all the other garbage in one folder, and it's in VS Code, we can know anything as long as we know how to read code. So, basically, if I want to have any clue how apply default options works, I will open VS Code. I'll have this folder opened in VS Code, so I'm actually in the same folder right here. And I will shift Control F, which does a find on the whole folder, what I'm looking for. And also to optimize your search, you'll probably want to exclude the docs folder and the extern folder, if you have them, because that's going to make your search take a lot longer. The extern folder is actually gigantic, and it's going to bring up a bunch of things you don't care about at all. So you want to add these to your excludes right there. And this other stuff is like, say if it's actually searching my song folder, then it's going to take literally years, and things like that. There's just other things we want to avoid here. Or you can do the opposite and only specify a particular folder tree. But anyways, this is what I would start with. Just exclude the extern and the docs folder. So yeah, we're searching for apply default options. We've got some things here, and really what this looks like at a first glance is we have other examples where this is being used, and then we've got, here's a header file where it's defaulting to false. That doesn't make too much sense to us. And then we start getting into the game command implementation file, and here's where it's initialized to false. And then we get down here, and there's another place where we have a bunch of other things going on here. A function called load1, which that's not really telling us everything yet, but we're getting the name of a command. Here's the name, and then we got to pick up all of the arguments from the command. And then it looks down here, and we have name is style, name is difficulty, announcer, name, text, mod, stage mod, Lua, screen, steps, set env, song group, sort, profile ID, URL, sound, prepare screen, stop music, apply default options, urlnoexit, set pref, fade music, and that's it. Now, what was I saying earlier? And this is the name. This is the name. This is the name. And the arguments are that, nothing, potentially, that, and so on. So, apply default options has no arguments. If it's present as a name in the game command definition, it's turned on. Well, that didn't help us very much, but what does this do? So, when this is true, we find this kind of looking logic. Hopefully you know C++, so this was really intuitive to you, but what is this actually, when does this run? Apply. Well, that probably means we're running the game command now. And there's a bunch of things that can happen for other conditions, but here is what apply default options does. It creates a temporary player options object, gets the default player options, assigns it to it, and applies the default options to the stage level of your player options. And it also does the same thing for the song options. There's actually separate things. Song options includes basically your music rate, and that's about it, actually. Song options is kind of useless. And player options is your CMod, your note skin, your scroll direction, your any transform, insert, remove, visual things, anything not relating to the Lua part of the customized gameplay, anything saved in the XML. Now, what does all these specific things do? Well, actually, we still really don't know where the default options come from. So we'll look up where does get default player options come from, and well, we don't want to go into the same places that we don't want to go into places that look exactly the same. But here is game state and CPP. And well, this must be the definition of this function. So there it is right there. Click that, and we go into here. What it's doing is it's defaulting the player options object to basically be empty, and then it's pulling default modifiers in from both your preferences and the metrics, and it's adding the default note skin. The preferences, they're going to be right here. You could look at this in the C++, or you can use your brain. Look in the save, in the preferences, and you have default modifiers right there. And there's also common metrics default modifiers. What does that even mean? Well, we don't know how this is set up, although I do, but I'm just going to say, for example, we don't really know how this is coming to be. This looks like it's a constant, but it's actually a dynamically loaded thing from your themes metrics. The common section, default modifiers. So we can control F for default modifiers, and we get so many results. It's really noisy. So we go down to a familiar file here, and we see themes fallback default modifiers, and we have the fallback theme right here. I mean, I can click that too, but here it is. We have the default note skin that I mentioned earlier, and the default modifiers. So we're kind of coming to a conclusion that this is setting the default player options for you. Well, why is it that when we do this, every time you press enter, it's not resetting your player options to the really unfortunate C400 default and the divide by 0 note skin that so many people love or hate? Well, the reason why is because it's setting the, let me go way back here. It's setting on the level stage. And we go into the mods levels, we have preferred stage, song, and current. What this means, well, I mean, the comments in the code really just lay it out for you here, but preferred are the options you have saved. Stage is basically whatever you're forcing for a particular stage. That means nothing to us in our current game, but basically it's like, you know, in DDR and Pump It Up and older Stepmania is every time you play one song or a course or a playlist or whatever, you would be on the first stage, second stage, third stage, final stage, and so on. That's what this is. And song is basically the same thing, except it considers a little bit more specific things. Tags actually don't exist in the game anymore, but there's that. And then the current is like the literal current conditions, the ones that you can see in front of you. So whenever you're setting, whenever you're forcing somebody's mods while you're in gameplay using Lua, you would basically be setting up stage or song, and it would be temporary. It wouldn't save, and it would transition the current to that using all the logic down here. But and if you set preferred, it would do nothing. It would just change what the player has saved. So there's that. So we're looking at this line again, right here. Whenever you press game start, we're applying default options, and we're sending the player to the whatever goes after the title menu. In this case, it's this screen, ScreenSelectProfile. And yeah, I really don't want to explain how this works. I mean, look at the code, honestly. With what I've just told you, look at the code. I'll show you where it is. For until death, the screen name is ScreenSelectProfile. It's not in one of these folders, so we go down to ScreenSelectProfile. We have an overlay and an underlay, and the underlay is specified as a redir. That's weird. Well, it's a file that you can just open with Notepad, and it points at generic BG. What in the world does this mean? Well, let me say what a redir is. It's a text file that simply names a path. And instead of the game loading the redir file raw, it looks at the path that you gave here and loads that instead. And there it is. Generic BG. So inside this, it's really just a black screen. So let me check. Yeah, it's whatever you see in the background here, which is basically nothing. And here is the overlay for the screen, which isn't really too much. It's just that we have this function here that's going to get all the profiles, and it's just too much to explain. I mean, what can I say here? I mean, it speaks for itself. Like, get local profiles is a function defined, and then we use that down here to specify the children that end up in the scroller, the actor scroller. And get number of local profiles is going to return the number of profiles that are in your save local profiles folder, which is going to be right here. And also, by the way, the names of these folders doesn't matter. You can change them. And then we have get local profile ID from index, get local profile from index, and what profile ID is these folder names. And profile from index means get this, which is your profile. And yeah, so this is how we have a person's profile given a number. And this gets your name, gets your rating. That's how this ends up here. And the number of songs you played, which is right here. And the rest of this is how the background, how the other graphics show up. For example, this is the lips on the top and bottom. This is this. And this is this. Okay. So, let's go in to select music. So we don't have any clue where any of this comes from, not knowing how the game works. So, say you want to make a Lua edit, a very simple edit to a file, or like, okay, let me think here. So, say you want to change what something on here is actually saying, or how something functions. Like, I don't know. You're the one editing the theme. I've done this for literally thousands of hours for like 10 years, but just think of something that you want to change. And how does it get here is what you want to answer the question to first. So I guess for some reason, maybe you want to show all 6 of these skill sets in a certain order here. We can actually do that. If you know anything about the game, what these 3 skill sets are is actually the top 3 relevant skill sets from 1, 2, 3 that show up here. It's actually just the highest, the second highest, and the third highest. So jump stream, tech stream, jump stream, tech stream. I mean, that's all it is. So, the other stipulation here is that it has to be within 10% or something. So there's that. That's why sometimes only 2 of them show up or only 1 of them shows up. But yeah, anyways, maybe you want to show all 6 of them. Maybe you want to show the order of the highest skill sets or the most relevant skill sets. Well, the thing about this is when I added translation to this theme, it made doing this a lot harder, but you can still figure it out. It just takes 2 extra steps. So let's try to do exactly what I normally do. This is actually exactly what I do if I want to go find the file that puts something on the screen. We say jump stream. Okay. We're opening VS Code and we've shift control F for jump stream. We have 150 results in 30 files. That's a lot. But it's probably not in the C++. And because the C++ doesn't put anything on the screen by default. Well, say the only reason something would be put on the screen by C++ is if nothing was defined or if something invoked it from Lua. And 99% of the time, it's not text. In the case of what you see on the screen right now, that is part of C++. It's like almost entirely C++. But for all intents and purposes, don't assume that anything that is here on the screen is actually from the C++. It's probably from the Lua. So now the next step is what theme are we in, and what file probably has this exactly written down. Well, we can narrow it down just a little bit. We go into a search that is by the case specifically, so it is jump stream like that. And since I know tildedeath is translated, I know that we can go into the language file for tildedeath and find jump stream there. But now I've run into a problem. I'm not finding the language file for tildedeath in these results. But that's okay, because jump stream, technical stream, all this stuff is actually defined in the fallback. It makes sense to put it in the fallback instead because it's common string. So we look in the fallback language file and we see jump stream, jump stream, jump stream, jump stream. That's very curious. And jump stream text and jump stream stored. Which of these actually does the thing that we care about? Well, just look at it and you'll find out. So what does jump stream text actually mean? Music wheel. What? Well, that's what I'm saying. So I actually know what this means. So that's actually this. And this here is sort order, which is actually, if I press enter here, it's the top right. This one, under skill sets, is what we're looking for. And jump stream short is not, but it's basically in the same place. So, okay. So we know where the string is here, but how do we get from here to the file that actually is putting it there? Well, here's how you load a string from the language files. We have to name a section in quotes. Amazing. There's our answer. So it seems that it's put in here into wife sundries in the fallback scripts. Seems like it's here, and it's also here, but not here. So it's either one of these is going to be the answer. So we'll shift control F for skill sets translated. And are we finding anything until death? We do have 4 results until death. which one is it? Is it here? This is the filter.lua file. Well, I don't think this has anything to do with the filter. Actually, filters.lua, if you woke up for a second, you would know this is the filter tab. Filters.lua is the filters tab. Okay, what about msd.lua? I mean, jump stream is a skill set, so it must be related to MSD, right? No. It's the MSD tab. I don't know how obvious that could have been. Okay. Now in the profile tab, in the profile Lua, we have the same thing again. Okay, well, ranking button text. I don't know about that one. Oh, there's another result down here. There's no name here. It's a little bit scary, but little bits is set up here. From 2 to the number of skill sets, set up little bits. What does this even do? What is R? And then R is apparently, where's the definition of R? If I go all the way back up here, here's the definition of R. That's kind of weird. What is all this? This is the profile.lua page. Oh, wait a second, we use half our brain. We go to the profile tab. It's this. Well, then it must be this. WifeTwirl.lua. Well, we got 3 results in this file. We have this, and this, this. Why are there 3 results? Well, it's because it's hard-coded, of course. In the General tab, you have 3 slots, and it's hard-coded to 3 slots, and it's literally copy-pasted, actually. You may notice that all of this code is exactly the same as this code, How did I know that WifeTwirl is the General tab? Great question. Maybe it's because these 3 things are present here. And also, if we start looking in the context, we have M, which is for a mirror score, a mirror PB. We have, actually, it doesn't say at the top of the file just because we're really cool like that. But this is, it's not really obvious what that is, but if we look in a little bit closer, it might be relating to the PB. Not sure. Let me go here. This is the rate for the displayed score. Okay, that was a really helpful comment. And then we've got the wife2 or wife3 indicator. Well, I mean, there it is, right here in the bottom left. Okay. We got goal information. If there's a goal, well, there's no goal here. There's a goal here. And I don't think it's there, so we go up to the one that has a goal. There doesn't appear to be one, so interesting. We got the date the score was on, max combo. This is looking pretty familiar to the first tab, the General tab. So here it is. All this stuff ends up here. WifeTwirl is the General tab until death. Now, back to our original point. We wanted to add 6 of these. So really, this is actually like a majority of the amount of time spent theming dead ass copy paste over and over and over and over and over and over and over. Okay. So we made our change. We restart the screen, reload the screen, and there's more of them. So there you go. It doesn't show 6 of them. I know why. That's because the way that the function works that puts the skill sets, it gives you the skill sets, is it only returns the 10% closest skill set to the max. So if you look at jump stream text stream stamina, it's within 10% of jump stream. But we don't see hand stream core jack speed here because they're not within 10% at all. But yeah. Okay. We go to another, like a multi-skill set file. Like, I got one. I think this one will have 5. Nope, okay. There we go. This one has 5. Multi-skill set file. But how do I know that it did the 10% thing? Well, let's just say we can Control-Shift-F for get relevant skill sets minus the rank. And now, here's where we get into how the Lua interacts with the C++. Basically, we're just going to go straight in and say, okay, so we have steps here, which we don't really know what this means, but if we go back to where it was defined, we have steps equals GameState.getCurrentSteps. Well, this means that we have GameState. We know that GameState is a global singleton. If we go back to this scuff documentation, we look at the Lua documentation here, we have GameState somewhere in this list. Here it is. I'm sure that was really informative for you. So, what this is going to return is from C++, get a steps object. And a steps object is the chart, is a specific chart. And that means that to know the methods that are on every steps object, we have to look at the C++ in the steps class. So if we did Control-Shift-F for this function and we found it in the steps class, we will find it, it's going to be looking like static auto or static int, like this. And also add method. If you find anything that says add method like this, it's definitely a Lua hook into a C++ function. And this is the definition for that hook. And it looks like what we're doing is we're pulling in the rate for the first float argument, and then a rank for the second integer argument. And then it's starting to do a bunch of weird things here. But if we look at it a little closer, we can see that it's sorting the skill sets at a rate based on literally 2 seconds of thinking or doing Control-Shift-F. You would know what this actually means is to take the skill sets for a given rate for a file and sort them highest to lowest. And then we got a list of skill sets sorted, and now we have this cutoff, 9.9. That's like 10%, right? And then here's the rank value at the given number. Basically, the rank is the 1, 2, 3, 4, 5, 6 that we passed there, and then the high value would be the first, the rank 1, the highest number. So what this is doing now down here is you put in 0, which is if you called the LuaFunction with a 1 here, then it's just going to be the first one. Fine. But the next ones are possibly 10% lower or more. So for everything subsequent to the rank 0, we need to start checking to make sure it's at least 90% of the max. So that's why this is here. And then if this passes, then it's going to give you that. And that's how sometimes these end up here, and sometimes they don't. And when they don't end up here, they actually are there. They're just blank strings because they failed the condition. So this is basically what I do every day, trying to figure out how a function works. And I run through this way faster than how I just explained it. But once you get used to this, it's really easy to just know how everything works. So yeah, we go back here. This is returning a string. It seems like. So we look at this logic, and it's saying we're going to recreate another string, and it's going to be based on if the SS is blank, and wait, this makes no sense. Well, this does make sense actually. It's a quirk of Lua. So this is a Lua ternary. If you don't know what a ternary is, it's basically a one-liner that is an if-else. So what this is saying is that if SS is blank, then the output is going to be blank. Otherwise, take the translated skill set that was passed by this. And we go look at the translated skill sets by name, and we see it's a table of the skill set names that would be returned by the game and translated to a specific thing. And then we want to know, again, we're just going backwards back from where we started. We go to the skill set section of the language file, and we look for something like jack speed, jump stream, hand stream, and we end up back in the language file. This is the rebirth one. And then we're here. So okay, so that's how you end up seeing jump stream and so on right here. Okay. So that's how this is. What I've reviewed so far is at a pretty high level how the theme works, but not how to kind of create one. You know. Okay, so here's what I can explain. In the theme folder also, we've got fonts, graphics, scripts, and sounds. And there's also other folders here, like other, docs, and some can have one called ThemeInfo. ThemeInfo is an optional thing. It's it just defines, it's a metric that defines the name of the theme that shows up in game. When you're selecting a theme, that's going to be on this screen right here. And the fonts folder contains a bitmap, a sprite sheet of the font that you want. I have another video about this, so I'm not going to go too much into that. And anything that's here and is not referenced directly there, but is referenced in game, is actually in the fallback fonts. And you can have readers here. So you've got common normal from the screen map. This is really confusing, but actually there's a bunch of C++ things that are loaded in text. I already said that, but this is how the font for those is defined. It's a bunch of readers. And yeah. So let me go over a couple of really useful functions for you. So we have theme.GetPath, and we'll look for the C++ definition of that. It's going to be in the theme manager, most likely. Reason why I would know it's in the theme manager is because theme manager is the C++ class name for call caps theme. But anyways, yeah, here we are at add method getPath. What all these mean is getPath font, GetPath graphic, GetPath bganimations, GetPath script, GetPath other. And yeah, I mean, again, here's where we've done the add method routine. Is like here's every single function you can call from Lua on a C++ class. They're all here, except for a few. There's a few. Let me find a one, for example. If we go to there's a couple of others that are defined. I think it's, oh jeez. Here's one. Yeah. Okay, here are the global functions defined in C++ for Lua. So you can just call isNetConnected, report style, and so on. You've got, here's a bunch of converters for weird strings and things, and here's other funny little functions here. Here's a bunch of things relating to dates. And there's those. There's a bunch of other things that are not completely totally clear, but you can actually, from C++, from Lua, you can call toStrings for certain types because they're automatically defined by a macro right here. So you can just be like radar category to string, and then it'd be like, okay, that's how that works. So this is that. But yeah, let me say, so we'll just look at a random file, for example, here. There's rebirth, and we'll say, let me look at the core bundle select. Oh, that's kind of useless. All right, let's look at the chat overlay, and we start seeing these things like message man broadcast, nsman isGB, theme get string. Here's a regular function. Regular functions. Theme get metric. Well, we know what metrics are, so this is going to be looking in the metric section for that item. That's what that means. And we've got current screen find. Well, we already know that current screen is a string, find is a Lua method, and there's that. So, here's a call of those global functions. Here's one in the singleton. Message man broadcast. Message man broadcast. Over and over. Let me tell you about message broad. Actually, here's one thing I mentioned way earlier that I just didn't get into detail about because I forgot about it. But there's let me just tell you what the definition of an actor is. So every actor, we'll open the title menu overlay for this one. So that is the definition for an actor. And what is an actor? It is simply the most basic form of an object in the game. It is so basic that there is nothing you can see if I was to reload the screen on the title menu right now. It is nothing, effectively. But maybe you have a question of what can I call on an actor? It's a really simple question, actually. Everything is an actor, unless it's a singleton, in which case it's like one of these manager things. And everything, here's all the methods. I mean, there it is. We're in the actor.c++ file, and here they are. what do they all do? Well, hopefully they have obvious names, and if they don't, like, heading, for example, like, what even does that mean? Okay, here's the definition of a heading for the hook. Adds rotation. What does add rotation do? Here's the C++ function. Now it's getting into freaking matrix multiplication and stuff. I don't know any of this. So, what this has to do is tweens. So let me get into a whole other topic there. So that's more business that I think about. But anyways, this is an actor. Inside of the definition of any, what should I say here? How about I say this? Def.actor is actually a function name, and when you write this table here, it's a parameter. So in the fallback scripts, we have this thing called the def table, the actor def table. And what it actually is any C++ registered Lua class can be invoked and arbitrarily placed using the def functions. So everything that is a registered class anything that has something that looks like this in it can be invoked by the def. And if you were way too lazy, the answer is already in the documentation. I put all those classes here. So you could say def.actor, def.actorSound, def.optionRow. That list actually stops right here. Def.WheelItemBase. You can't def.chart or anything like that. These are not actors. These are just types. Actually, I think these are not in the right place. You can't def.screen. You can def.sprite. You can't def.game. You can't def.playlist. Anyways. So we're here with the def.actor. Well, I'll just say straight out of the gate, these are the commands that apply to every single actor in existence throughout their life cycle. Actually, this one sucks. Don't even think about that one. Okay. What is a command? Well, it's similar to the thing that I talked about way earlier, where there's a game command thing, and it's defined in metrics. But the thing about this is like a Lua function that you can just attach to anything and just call it. So the init command occurs at a point in time in which the screen is loading and the screen doesn't actually exist yet. So doing this actually would be null. And you wouldn't want to write anything that relies on the screen existing at this point. But the very first thing that happens when a screen is loaded is we have begin command. Right here. And then we have on command, which occurs in most screens. And end command is End command is what gets run when an actor is being destroyed, and most of the time that is occurring when the screen is closing, when it's exiting. During the transition from one screen to another, end command will be run on everything. So we can validate all this. If we say ms.ok 1, 2, 3, 4, and we have an actor on the main screen, and if we go to the main screen, we see 3. Look in the logs and it says 1, 2, 3, and we see 1 was run really early. We loaded the screen menu and thrown it up to the screen that makes it visible. Then we have 2, 3. So everything ran in the order that I said. 4 hasn't run yet, but by I switch screens, 4. So 4 ran right before it exited and went to the next screen. There you go. There's a bit of a lifetime for actors. So, there's more that we can do with commands. Here is an arbitrarily named command. You can actually just give anything you want here, but it has to end in command, like that. And I will show you how this works. We can trigger a command to play from another one. You can't call the function directly. You can't say this. That doesn't work. You also can't do this. That does not work. You can run an actor command, an actor function, by the way. If we go back here, we're going to go into the actors again, and we've got these things. That's interesting. Everything can do this. Play command, given the string name of a command, will immediately execute that function on this line. So, we'll do this. 2, run this command, 2.5. And also remember, we have this other one that's defined as 6, and random name is defined as 5. So I've saved it, and I go back to the title menu. 3. Well, look at the logs. What actually happened? So we hit, let me rename these real quick. Okay, make this a little bit more clear for you. So we had init begin start, which is like that, okay? Begin start, random name, begin end, on. Okay, so what do we have an alternative for here is we have a Q command. And what does that do? It changed the order. Init, begin start, begin end, on, random name. That's really weird, right? Begin start, random name, begin end didn't match this order. Well, here's where we get into the topic of tweens and queuing tweens. It's complicated. I'll get into that in a couple minutes. So I'll just let you sit with that for a second. But play command is what you would do if you want something to run immediately, right now, right at that time, right at that moment, in that order of execution. And this thing can recurse. You can go into things and let me just, we can do this. So we will be that, this, that, right? Reload the screen. Oh. Okay. And here we have init. Begin start, random name, random begin end on. There you go. You can recurse these really deep. What you want to avoid, you do not want to play command itself. That is, I mean, that's literally just shooting yourself. It's, that will crash the game. Actually, it won't even crash the game. It will say, it'll freeze you. You'll get a hard freeze, and you won't be able to get out of it unless you close the game. So don't do that. Q command can do the same thing. So just try not to do that. It's other languages that are a little bit safer would say Stack Overflow, and you would crash. But Lua does things the way that we're running it doesn't really care too much about that. So you would just hard freeze until, of course, the function stops running, but it never stops running. Let me think for a second. Okay, so there's another type of command here. We have a message command. What in the world is that? Well, we can play it. So what even is it? How does it work? Begin start, something else, begin end. Does this mean that its name is something else message? No, because I can play command something else and it'll work. It means that it's a message command. I was lying earlier when I said everything is an actor. Technically, everything is a message subscriber. There is one level higher than an actor. It is a message subscriber. So, what is a message subscriber? You don't really have to be concerned with how that works specifically, but basically there is a singleton called the message manager. And what it does is handles the subscription and distribution of particular messages that may or may not contain data, and any actor can subscribe to any message arbitrarily. The data being transferred across the messages can be anything, and basically the point of it is to, I mean, how it's you want to communicate remotely with an actor in the game, and you don't know if it exists, and it may also be troublesome to go invoke it directly. Basically, you can't just play command, like, say if I did this and then I wrote another sibling over here that had this. That I cannot expect that when this begin command runs, I can't think that something else is going to go down here and trigger this. It's part of another child. It's actually a sibling of this actor. Instead, something else is going to refer straight to this. And I can show you this in action. init begin start something else begin end on. So this was never invoked. But let me do this, and broadcast at its basic form is really it's a play command that works globally. So you can say the name of the command and it works. Init begin start something else begin end. Right? Well, here's the thing. If you look at it a little closer for a second, begin start something else begin end. Didn't we say we wanted to maybe communicate with this, right? Well, it's not registered. It's just a command. This actually was registered as a command because it's a message command, right? So we can change this to a message command and reload the screen, and the truth comes out. Begin start something else wrong begin end on. So begin start something else wrong here and here and end. Now here is the very, very good thing to know about messages. They execute in a random order. This is why you don't want to rely on them happening in a particular order. So if there's a bunch of things subscribed to one message, it is not reliable to say that they're all going to happen in a certain order. I mean, technically, I know that there is an order to it, but the order is the order in which they register. And the order in which they register is very vaguely top to bottom in the file. You can't really just rely on that, though, because an actor can be destroyed and created at runtime. And the list of messages can be sorted randomly. So it's just not something you want to rely on. Okay, so let's see here. Something we kind of figured out by implying it was if we do a play command on this, right? This works to invoke something that is immediately local, and it actually works. Like a play command actually does work on a message command. Message commands are only different from the commands in the fact that they can be invoked by a global message. Message broadcasts cannot be queued directly, the same way that a queue command would work. That's one thing to think about. All right. Okay, so let's get into queuing and tweens. And to do that, I want to change this actor type so it's visible. We're going to change to a quad. And a quad is right here, somewhere in this list. I hope. No, a quad is here somewhere. Here it is. So quads are actually sprites. That's why when you search for add method, you don't really know what a quad can do without knowing that it's a sprite. So yeah, wrap your mind around that. So yeah. Okay, so a quad. And what is a quad? We'll just load it real quick. Where is it? It's that tiny dot there. By default, it is a 1 pixel dot at location 0, 0. So we'll move it around and resize it for you. We'll say move it to the center of the screen, and we're gonna make it 200 by 200. Now it's right there in front of you. Okay, so now we'll demonstrate tweens and queuing them. Let's say we'll set the color of this thing to red. Now it's red, okay? So in the something else command, we'll say, we'll set it green. Now it's green. You never got to see it be red. That's because begin start, hit the diffuse, it set the color, in the same frame it ran something else, and this overrode it before it could be redrawn. So it's green. You never got to see it be red. But what happens if we queue it? It still just immediately goes green. That was on purpose though. We queued it so that it executed late, but it was not late enough. By the time it shows up on the screen, we didn't get to see that it was in fact red for maybe a frame. So here's what we can do to delay it. This is one of the several defined tween what do you call them? Like delayers or timers? Basically, sleep will just pause the execution for the amount of time given in seconds. 1 second is how long this is going to wait. So what this should do is we hit a knit, begin start, it's going to set the color red, it'll stop for a second, and it'll queue this after 1 second to change it to green. Here's what it'll look like. There you go. Okay, but what if we wanted to make it so that it gradually did that? Well, sleep is just a stop and then start. There are other different ones, like here in the top left, we can actually see them all next to each other. Sleep, linear, accelerate, decelerate, spring, and tween are the ones that are part of the C++. There's a few other ones defined by, for your convenience, over here in the fallback scripts somewhere. Most likely they're in the actor file here. Yep. Here's ease as another one. And bounce begin, bounce end, smooth, drop, and compound. Okay. So we'll just take one that's in C++. It's always available to us. Although the fallback ones are also usually available to us all the time, but the C++ ones are just are based on the exe of your game instead of the theme, so it's really helpful to use those. Linear one will linearly execute the next command. But that was kind of strange how it just hopped over to the next command, right? Well, there's a quirk about how this works. So when we queue a command and we try to tween it, like delay it, then what it actually is doing is it's not putting the contents of this command behind this tween. It's executing this command after this tween. So we're setting a state initially. This is the current tween state. And we're going to delay for 1 second to execute the next command. To execute the next line, basically. Which is to immediately switch it to this. So changing this between sleep and linear actually didn't do anything for us. The answer here is we want to queue a command which linearly for 1 second switches the color. So the way that's going to work is it's going to be red at first, and after 1 second over the course of the next 1 second it fades into green. There you go. That was a little fast, so I can do it over 5 seconds. So that's what it looks like to transition tween states. You have an initial state, and then you're running another command. The command sets a tween that lasts for 5 seconds to set up the next state. And here's where we can get a little more fancy. We can add more things here. And they can either be on this line or they can be on this line. They do the exact same thing. So there you go. And they run at the same time because there's no tween queuers in between them. And one more thing is you can define multiple you can define and queue multiple states in the same command, which is perfectly fine. So what I'm doing here is I'm going to set this. Okay. So what it's doing now is we set initial state to red, and then we queue this other command down here. What this other command is going to do is over the next 5 seconds, it sets it to green and moves it to the right by 100 units. Then at the end of the 5 seconds, it will spend another 5 seconds setting the color to blue and move it back to the left by 200, which will put it effectively a net left 100. So this will take about 10 seconds. There you go. So this is how tweening works. And you can just keep putting these all over on top of each other. Yeah. Play command would do the same thing. Okay, think about this. Think about it this way. So if we did Q command, this means to delay the execution of this function at the next frame, at least, unless we did something like this, which would sit in this function for a second, then execute this function at the next frame. Q command always just throws it on the next frame / next time the tweens are evaluated. If we did play command, it actually wouldn't do anything different for us, except for it'd be the same as taking this and putting it here. So we'll try it. It's going to run the exact same way, but it will immediately start, and the order of execution didn't really change because they're just defining tweens at the end of the day. So that's how it is. So one thing here though is, say for example, you want to run multiple things in this function and also trigger the beginning of an animation that you don't want to wait on. what you would do is queue the command. Because if you played it, it would, again, be like sitting there and waiting for all this to finish running. But if you queued it, it would queue this to run later. For example, let me do... This is a good thing to try here. How about... Let's try this. What does a play command do to delay this linear 3 seconds move to x250? Notice how it kind of overrode what we tried to do. Pretty peculiar. What does it do now? Okay. The net result is different because we queued it. That's all I can say about that. Queuing and playing can override things in an unexpected way. All right. So, and let me just show you that a play command is going to be basically the same thing as a broadcast. As you can see, it's animating. There's one more thing you can do with message broadcasts, and that is they can have parameter tables in them. So, like this, and then you can refer to them as another parameter to the function. So we can say like ms.ok params.a, and it will actually print 1 here. So, there it is, right there. And that's how you would transfer data across to something like this. Now we see 1 twice. Another thing here is a play command actually lets you do the same thing. But notice we only see 1, 1. Because it's hitting this one. It's not hitting this one. So how can we hit this one with a play command or a queue command? It's actually really easy. You need to know how to traverse the actor tree. And to do that, you get the reference to your parent, and usually this works if it's a sibling. Or if you want to be really specific, you have to get the child by name. I haven't named it, so this is an important thing you want to try to do as much as you can. Give every actor, anything you create, a name. It's okay if the name is not unique, but if it's not unique, then it will make your life difficult. So we can get it by name, and then we play the command on it. It won't play this, but it will play this. You can see, it didn't animate, it did run, it did 1, and then it did wrong. It did not do any of this. And it went here. And you can also do the same thing to queue. You you won't really see much of a difference there, other than the order of execution. And by default, pretty often the way that a command will work on a parent is that it just gets distributed to all the children. So if I did a Q command on the parent of something else, it triggered both of the things to happen. Problem that you might have just noticed, actually, I only showed it for like half a frame, but we don't see one printing out, even though these things say params A, and I passed one. That was because I did a Q command. A Q command does not keep a parameter table. This is not possible. So a play command lets you pass a parameter table. And now we have ones again. So what I've just shown is that from a parent, a command being played by a function like that, it's recursive. It distributes it to all the children. Okay. So now I'm going to show you how an actor frame works. Technically, we've been working with one this entire time. Normally, when we're defining the layers to a screen, every time we return it, we want to define an actor frame. But the good news is you can infinitely nest actor frames, because really what they are is containers of actors. So this is how you would define an actor frame. You create an actor frame. What this means right here is to add a new element to T, and these def functions return tables, and this means add a new element to the end of the table. That's all it is. So we're adding an actor frame as the second element in this actor frame. Let's give it a name because I feel like it, and we can give it an init command if we want. And now we have to define its children. Well, we've done it. There's one child. This is now an actor frame with one child that is a quad. And this is I don't know what you would call this, the uncle? I don't know. It's a relative of, it's a distant relative of this, this quad, okay? And, yeah. So, we can continue to define more of these things. So, like this, and etc. But it works all the same. And you can continue to repeat these command names, as long as you're not saying something like this. Like, you can't do this. Particularly, you can. I think it won't throw an error, but the problem is this is like not valid Lua. So what this actually is that you're doing here is you're building a table, and really it's like saying this. That makes no sense. So this is just like not a normal thing to do. But what this means is inside the actor frames table, we have created a name. Here is the init command for the actor. This is a nested quad. Here's another nested quad. They are not the same. They return different tables. There's not any name here. Think of this as like an array, and then every time we're doing like, it's mostly an array. It's not really an array. So the what this actually looks like if you flattened it out would probably be like name init command, and then you would have like 1 and then 2. So it looks kind of like that. if you like really oversimplified this, it looks like this. And that's why that is why this works. Because what this does, what the in Lua syntax, what number t does is it gets the highest number, and even if it's got other garbage in the thing. So what this will do then is number t plus 1. It'll throw in 3. So there's that, and that's how that works. Okay. So, as I was saying, what is an actor frame? How does it work? Well, actor frames are actors, so all of these functions apply, as well as any actor frame functions. So we can actually arbitrarily add children and remove children at runtime, and we can also change the order at which the children are rendered, and we can change certain other interesting things. So here's something cool that an actor frame can do, and it's really helpful, is every actor frame can define an update function. And really, it is what it looks like. It's a function that runs quite often. By default, I think it might be 10 times a second. I don't remember. It's fairly fast, but you can change that to this. You can change it with this function, that update interval. So if we go here, well, I didn't expect that. What? Okay. So what that number actually is the amount of time between every time the function was run. And this is the kind of thing that you would use to make physics frame rate independent, basically. Because as you can see, as the frame rate changes, that number changes. It's the amount of time between every frame. When I tab out of the game like this, it reduces the frame rate of the game to like 80, I think. Like right now, my frame rate is about 1,000. That number is basically 1 millisecond. If I tab out, it goes down to 90-ish, and it's like 11 milliseconds. So there's that. And then this is a function that runs every time, so that's why we have this right here. I would not recommend putting any tweens in here, because that will really screw you up. But you can like do things like finish tweening on something. What finish tweening will do is, say if you've queued like a bunch of tweens, what finish tweening will do is immediately send you to the last one. It skips all the other ones. There's also stop tweening and hurry tweening, which do what they sound like. It freezes the tweening, and hurry tweening will speed up the tween process by a multiplier that you give it. That's all. Okay. Another thing here is the actor frame as a container. Since it is an actor, it can also have its own position and sizing, and also it can have its own rotation. So let me not play this command, and we'll see that box is way down here. There's also that dot there. That dot is this quad right here. So if I get rid of that, it's gone. Technically that dot, okay, we'll actually put that back. So that this quad is representing
the relative position of all the children in an actor frame is the actor frame's position. So this quad has nothing defined inside of it. It's at 0, 0 relative to this actor frame. And this actor frame is at 100, 100. 100, 100 is right here. So this is actually where the actor frame is sitting. And that means that this square has been offset by that much. So if I set this back to 0, it's back to where we remember it being. And then that dot's back up here. You can't really see it. But if I do this, you can see it. Okay. And as some more examples here, we'll put it back down in the like that. We can change the zoom. What this actually does is it applies to everything, all the children. So 1.5 zoom is going to make everything 1.5 times larger, including the coordinates. So it's like zooming the entire frame, literally. And the rotation Z is going to rotate everything visibly on the Z axis. We'll go with 15 degrees, because I think if I do it too much, it's going to go off the screen. Yep. So this has been rotated a little bit. Yeah, I think that's right. It's moved basically. Think of it. You have a piece of paper, and you have things on the top left of it and the bottom right of it. If you rotate the piece of paper, where will everything be offset? That's what this has done. So wait at 45. What's that going to look like? Yeah. Okay. So 0, 0 is like up here, and then this is down here. Rotate Z is like spinning it visibly. The reason I don't do rotate Y, rotate X is it's rotating it forwards and to the side, and it's basically invisible to you, the changes. Okay. That's pretty much it for what an actor frame can do. I mean, like, there's some other details in here, but like, that's just how it is. I mean, what you really want to be really detailed on is the fact that you can do a lot with actor frames. You can put actor frames in actor frames. Every screen is an actor frame. So that's why we're doing all this T+1 stuff. Every time we're finding what a screen is, we're just putting actor frames and actor frames over and over. And that's how all the stuff gets on the screen. Yeah. Okay. Let's see, what else can I talk about? I'll talk about scripts and globals and the scope of Lua as it runs in the game. So, you may have noticed in the base folder of the game, we have background effects, background transitions, bganimations, and scripts. I would ignore all of that. The scripts folder, you may not want to totally ignore. This is loaded globally for the entire game, and any function defined in here that's not local, so it's a global function, is available to all the code running in the game, independent of the themes. The reason why we put most of our global functions in the fallback is it gives it a smaller scope, just a little bit, but it's in a more obvious place. Also, the way that works is in every theme you have a scripts folder that loads before all the screens, and you can define globals here as well. So this is a local, so it's not available to everything, but this is a global right here, and this is how the color config is accessible from everywhere in the theme. And this is a global function that you can just call anywhere you want, and it works. But it only works in this theme till death. And that's why doing things like relying on these things to exist is a really bad idea from like a note skin point of view, or a toasty point of view. You only want to rely on things that are in fallback or in the C++. Yeah. And for example, the way the order in which they load is going to be this scripts folder, and then it's going to be whatever fallback theme you have defined. So in this case, it's fallback, and then it's going to be actually, what is this? Oh yeah, I mean, it's loaded in the alphabetical order here, and then it's loaded the scripts folder of the theme you have selected in alphabetical order. So you may have seen that some of these have the same file names. That's intentional. And some of the contents of the files have the same global variables and functions defined. And what that'll do is replace anything that already existed with the same name. And that's how you override things in your own theme. So, there you go. And a lot of the functionality in the game is defined by the scripts, not just by the C++. Like this load actor right here is not in C++. It's actually a defined function in the fallback scripts. Right here. Just like the actor def, but actor def is a little bit more special. But load actor is, it's taking advantage of actor def in a certain way so that you can slightly quicker load a certain file type straight in as an actor. So if you I mean, this is what it is. I don't know what else to say about it. If you say load actor and you pass a picture, like an image, you'll get a sprite. You say load actor and you pass a sound, like an MP3, you get a def.sound. And you pass a folder, you'll get a BG animation, which might not work anymore. And if you say load actor and you give a Lua file, then I mean you just get whatever the Lua file is. And load actor is done in such an intelligent way that it actually knows what folder that you are running it in. So it's absolute. It's relative, not absolute. Right. One other thing here is for every time you are, so you may see here there's this screen in out background thing. What this actually does is it defines the in and out transitions of every screen. Screen as a class is the base class of all screens. So anything that doesn't inherit a specific screen, or anything that does inherit any screen actually, it would just go back to all the way to screen. If there's an out defined at a higher level, such as ScreenSelectMusic, it'll override screen out. So what the screen out is doing is it's like a fade to black, I think. Yeah. And ScreenSelectMusic has some custom logic in here so that when you go into here, you may see the okay, so you see the fade to black here on those two screens. But when I press enter here and it fades to black, well, okay, it didn't actually show anything, so let me let me show you. So the custom logic in ScreenSelectMusic here is to show this, to tell you that you can press enter a second time. That's what this does, and that's what this does. Okay. Okay, one other thing that I want to talk about is that there is actually a whole other screen type called an overlay, and it is separate from the overlay layer of regular screens. Let me turn this off. Okay, you may notice that there's this, when I do MSOK, there's an image, there's a message at the top, and there's the FPS thing on the top right, and there's the entire debug menu, And there is also the multiplayer chat menu that is right here. And there's also the thing that shows up when you do Control Q, and there's also the thing that shows up when you download a pack. All of those are overlay screens. Okay, well, those are defined in the metrics of your theme. So, find it. Okay, here's the list of overlay screens that load in your theme. This is the fallback one, I think. So, I don't remember what this is, but anyways, it's not important. This is the list of overlay screens that can be loaded in this theme. Install overlays for the Control Q, debug overlay is the debug screen, the stats overlay is the F3 FPS counter, the sync overlay is the in-game auto sync and the F11, F12 menu. System layer is the thing that shows the Lua errors and screen messages. And also, actually, I think this has the pack downloads on it also. Install overlay has something maybe different. And chat overlay is the chat. You can define your own overlay screens the same way that any other screen is defined. The only difference is that overlay screens are always loaded. Always in that order. So if I go into here, you see that option 7 reloads the overlay screens. And all it does is it just reloads them. The shortcut for that is Control-Shift-F2. It flashes that because that's actually, there's some of them have transitions defined for some reason. So that's just why it looks like that. But you never ever see those transitions in any other context. So that's what it does. Also, you may notice if I go to F6 here and I do reload the screen, the overlays, it resets that. That's because the debug menu is an overlay screen. Part of the overlay in Till Death and Rebirth is the mouse logic and the button logic. So if you ever reload the overlays and that breaks, that's probably why. Yeah. Another thing to think about is anytime you modify the global functions like the scripts files, you want to Control F2, which reloads the scripts. That also resets all the global variables that did exist before, which can again break a lot of logic and internal themes. That's why when you reload scripts, you probably want to do a reload on the screen also. And that'll pretty much get you back in a normal state. Regularly pressing F2 or pressing F6 on this screen will reload every texture that is cached and refresh some of the directories like the noteskin directories. Hitting Shift F2 will reload the metrics, and that includes any INI file that the game has loaded, and that includes the language files, the noteskin.inis, the theme metrics, and anything else that's an INI. The fonts, yeah, that's who. That's pretty much that. Okay. If you ever wanted to know how to define these rows in options, actually let me go to a better example. These rows, then look no further, because the answer is in metrics for the 10 millionth time. So here is, well, this is probably okay. So we'll go to the theme options. So this is Screen Options Theme, and we're in the Screen Options Theme metrics entry. And we have the line names, and these are the names for each of these definitions of the lines. And as you can see, they are loaded in the order that I have defined the line names. And some of these line names are different. I mean, they're not really that different. I mean, these are still game commands, You have a function name and a parameter. But they're actually a little different from GameCommands in that these are option row definitions. What this means is Lua and conf are the possible names, and the parameter passed is the table by which the definition needs to load. Conf loads from the C++ configurations that are defined. So this is actually the name of a function that's defined in C++, so we just made available to everybody. And this runs a particular Lua function that returns a table. And we want to know where to find or what this actually does. Again, answered all your questions. Ctrl-Shift-F, look for the function definition. Here it is. It's returning a table, and this is a Lua option row definition table. You have to give a name. This will be the name that shows up on the left here. The layout type is how the options are displayed. It's either going to be, well, this only shows one type, but basically there's that one type there, and there's this one. It only shows one option. And then select type is you can select one, you can select multiple. Like the different options, by the way, are available if you select. You Control-Shift-F and you look for where they're defined, which can be right here. Select one, select multiple, select none. Show all in rows, show one in row. So on. So there's that. One choice for all players. This is an old thing, remnant of Player 2. So it just doesn't matter if you say yes or no here. Export on change means that it will run this function every time you touch the option and change it. Export on cancel means that it will run this function anytime that you press escape to close the screen. That is not a saving action, that is a canceling action. Choices defines the order and the strings by which the choices show up on the screen. These are things coming from the language files in this case, but it can also be like a list of numbers. So a lot of these things are just strings, and then these are just numbers. So that load selections is how the option gets set to what you can see right down by default here. It's loading it from your configuration, and save selections is how we save the data. There's a couple extra things here I think that aren't relevant usually, so there's not there. And that's how we put these things on the screen. The list of conf options is hiding away over here in Screen Options Master Prefs. I think. Should be. Yep. Okay. So this whole list here in the initialize conf options function this is the name you would refer to it by. So game, language, theme, announcer, and about 100 other things here. So you can't change any of this yourself unless you're going to go modify to C++, but these are the names you want to refer to things by. So this conf show backgrounds here is, if I can find it, right here. It says that it's an on-off preference. That's all. And what it'll probably do is if you turn this on or off, it'll change your background's preference. So we can verify that. If we go into preferences, and there is show backgrounds. So there it is. There's a bunch of other things in metrics I haven't talked about because it's just, there's a lot. For example, actually, really, we could just look at anything here and just answer the question by Control-Shift-F. So, screen text entry, question X, question Y, question on command, question off command, X, answer X, Y. What does all this do? Well, Where is question Y? Where is question X? That didn't really answer the question. So, next up, what is question? Hopefully we can find it in the context of screen text entry. And then we have where something is being referred to as the name question in the initialization of the screen text entry. And then there's a peculiar thing here. It's a macro in C++ called load all commands. You would never guess what this does. It loads all the commands. What that actually means is it's going to load every question X command that that's listed here. So I can actually say something like this. And that would also load, although it would be basically not accessible to anything. I mean, it would be accessible to anything that knows it's there, but it's pretty much useless if you're defining it in metrics. There's not much other places you would use it. Okay, so we go back here. On the init, we're loading those questions, but where does question X get used? Where does answer X get used? Well, what does set XY do? Again, Ctrl-Shift-F tells us why, tells us how. Set XY, I wonder what that does. Set XY is part of ActorUtil, so we look in ActorUtil, there's the function. Actor metrics group. Metrics group is going to be screen text entry. And the actor name was question, because we saw it back there. So what it's going to do is it's going to take the metric from question get metric F is a float. It's going to take a float value from this thing interpreted. So question X, question Y. What is the X value? What is the Y value? And then it just does set XY. And what that is the XY command that I showed you right here. That's all it's doing. So whenever you open a screen text entry until death, which is right here, for example, that's how the stuff gets put where it is. And then we have the on command and the off command. What these are doing is this is the game command metrics format for Lua functions. So function name parameter 1, function name parameter 1, function name parameter 1. And where is the on command run? Well, if we go back, I believe the answer to that is it's automatically run when the screen loads, or it's here, I think. Check. Maybe not. Okay, so I think I'm going to take a good guess and say that it is just at the basic point at which it should load, which is when the screen appears. When the screen has done, actually, yeah, it'd be right here. So begin screen would be what triggered that, probably. I would go look for it, but I mean, it's more noise to this boring presentation. Okay. So, just by a little bit of analysis, you can figure out where these come from, what these do. And if we looked at music wheel type here, music wheel X, music wheel Y, it would be the same deal. Here's another thing, codes. There's something in the game called code detector. We want to avoid using that, but what it can do is do like a button combination. We really just use them for changing your difficulty and for the rate buttons until death. I really don't want to talk about how they work because I want to avoid spreading the usage of these. But pretty much what they do is they load from a script, and then they, based on a name, they'll load from a script. It's defined by a string using a bunch of these things. The result of the script looks like this, basically. And the code names for a particular screen is the list of codes that are loaded on a screen and can be run. And when a code gets executed, gets triggered, it's like a message broadcast to the screen. So it's a code message command. For example, here. This is one that's in the overlay default that is opening the asset settings if you press avatar show, which should be the select option by default. So if I press / twice, there you go. That's how that works. That's how that shows up on the screen. I was to press avatar show, which is select. So I'm going to press it. There you go. Here is an example of how you would define an entire function in the metrics thing, in the metrics format. So you can actually write a LuaFunction with the parameters here. This is how you would go to the next line, technically. Basically what this means is we're going to the next line and we don't want parsing to stop. Basically ignore the next character. It's so you can write it in a more human readable way. And then write your code pretty much. It's got to end because it's a valid function. And I know what this does already. This is the this is what's defining the position of the items on the title screen. So for every individual item, it's setting a particular Y position on an index. So 1, 2, 3, 4, 5, 6, 7, 8, 9, whatever. So there's that. For the music wheel, there's also something similar. So let's see. Let's just find it. Is it here? There it is. Item transform function. It's putting it at the. It's not moving it horizontally, but it's moving it vertically at 38 times whatever the offset is. And the offset is changing once per frame to a very small number, and that's why you get the animation here if we do this. And very fun fact, there are more options, there are more items than you can actually see if you go off the screen. Then we have the scroll bar, and that's this thing on the right here. And there's some other things that just aren't used. If you're ever wondering what a text banner is, it's the information that shows up on an item. And with the case of a lot of C++ defined objects like the text banner, you can actually define a lot of their logic in graphics. So with the music wheel items, we have music wheel item grades, which defines how the appearance of the grades is. And we have music wheel highlight, which is why the lighter shaded rectangle is here. We have music wheel item song normal part, which is the basically this is the thing that contains most of the information on the music wheel. And in other words, that is the actor frame with the button. And that's how when you click on the wheel, it moves it. Okay. And then you have surprised there was nothing about the text banner here. Scroll bar tick thumb is this. I think. Yep. Okay. Note field board is the background of the note field. There's also a note field overlay, I think is what it's called. BPM display is the Lua definition for the BPM display right here. Steps display row, list, frame, and steps type. I think those are not used. Until death, we've replaced it with our own thing. These are how they would be accessed. Graph display is actually this thing, top left. It's the life graph. Combo graph is the other thing here. The way that they work is really integrated with the graphics. It's almost entirely just the graphics folder and the metrics file, so they're really annoying to work with. This is where the judgment and the combo for the theme is located, also in the graphics. And then you can just put your other own garbage here. So we just have random things in here that get loaded by regular files. We invoke theme.getPath g from. Okay. Okay, so I mean, honestly, I could sit here talking for another like 10 hours. I don't know what to really go through. The next thing I could do for you is I could explain in great detail what every single one of these things does. The problem is, why? You know? Pretty much what you want to be doing when you're creating your own theme from scratch is you want to take the things that already exist and use them for your own. So this is what Rebirth did. For Rebirth, I took this screen and I understood it and copied it and pasted it into Rebirth. It's where everything started, really. So everything here works the same, roughly. And I wrote both of them, so there's that. But like, once you know how a theme works just by looking through it, you can make your own changes and eventually translate that to your own thing from scratch. Note skins are a decent place to start because it gets you interested in, it gets you a little saturated in a closed context. So, for example, we're looking at divide by 0 here. The only thing you can do in a note skin, I mean, you can actually do a lot in a note skin, like literally anything. But the thing is, note skins conventionally are restricted to defining what every column does in your note field. So it's trying to teach you how there are certain Lua thread variables like the vars here, how to pull in things, pull in information from loading a Lua file like this, how tables and ternaries work, which is this. Saying like the way the syntax works is it's saying it's either pick this, or if it doesn't exist, then pick this. This is saying, this is obvious. This is a load actor. You use this all the time in a theme. This loads a Lua file or an object or anything from a path. sprite only is another one of these things that can only load sprites. It's for old bodies. And base rotation Z is one of those when you're defining an actor, like let me show you. When you're doing this, you can actually say this. That's a valid thing you're allowed to do, and this is in addition to the rotation Z that you can apply by doing it with functions and commands. There's a base rotation and a base sizing and a base position and all that stuff. And if you ever wondered how those get pulled in and what attributes you can actually use, you look for load from node, and these are all the values you can set for an actor. Command name, or actually, this is how all the commands get loaded that I've been showing you this whole time. This is the name for the actor, the base rotation, the base zoom, and this is for every actor. And then immediately after all the things are loaded, run the init command. And in the actor frame, it's the same, except now there's more options. You have the update rate, the FOV. This is, I do not mess with this, probably. The vanish, that's also another one of these things you don't want to mess with if you don't know what you're doing. Lighting, that's another thing. And I mean, there's just a lot of things you really don't really make a lot of sense, but they exist. We got actor multi-vertex. This is the thing that creates the offset plot texture. There you go. Actor proxy doesn't have anything. It's actually just an actor. Actor scroller. Number of items, transform, subdivisions, masking, scrolling. That's how the select profile until death is defined. It uses children as another sub-element and defines them. Actor sound, panning, actions, pre-caching. This is loading in memory, by the way. If you have an actor sound loaded in Lua, it is always in memory. Contrary to like the gameplay, which is not. Here is a bitmap text, which a raw bitmap text has to require you to put in text and a font or the file that defines the font, and that is annoying. And that's why we almost always load actor a font name, and that does most of this for you. Models are literal 3D models that nobody knows how they work. The file format is milkshape ASCII 3D. Quads are sprites, and sprites let you load a texture, and you can define the frames in a sprite sheet. If you've seen this in a note skin, you might have seen this in a note skin that animates itself. You can have hold judgments. Normally they're invisible. Note field preview is a newer thing that loads a note field, but you can't interact with it. It just runs the note data through. BG animation is another thing. Meter display is to display the difficulty. Actually, no. Meter display is for this is for this is for the song progress meter. It's kind of weird. Difficulty list is the C++ version of the steps display. TextBanner is the music wheel item information metadata. And if you look, if you start getting into X nodes for interesting. I'll have to think about that one sometime. But basically, not all load from nodes load from Lua. Score goals are coming from the Etterna XML. Like note data here is, I'm surprised that's even here. XML profile, yeah, you can't define this in Lua. So here's here's the list of the Lua thread variables that are available to a node skin. Player, controller, button, element, sprite only, color, current node skin is the name of the node skin. I'm really running out of things to talk about here. So let's see. And I want to just demonstrate this again. I want to say this a million times over. If you don't know what something does, just Control-Shift-F. There's the definition. What does this even mean? Well, Control-Shift-F. Keep figuring it out. If you can't figure out what it does from the definition of it, change it and then see what it does. Like, if I'm sitting here in WifeTwirl and I don't have any clue what this stuff does, like I want to. What happens if I want to find something that's not weird? Yeah, okay. So what does it mean to set text here for some reason? What are the conditions under which this would show up? I mean, obviously, this is the condition. So, can I get that to show up? Interesting that it shows up like that. Okay. Now I have to think about why. Why is this specific scenario? Well, there's the condition right here. If song. What this means in Lua is if song is not nil. Song is nil if I'm not on a song. So logically it comes down here. That's all. Okay. I'll just be a little bit extra generous here. This is the I'll tell you what all of these individual files do. Actually, I won't, because they're by name. I mean, it's really obvious. I don't know what more information you could gather just from me telling you here. Screen player options is the player options. Screen pack downloader is the pack downloader. Net select music is the net select music. I mean, or bundle select, I'm about to remove that, so that doesn't do anything. But asset settings. What more do you want? Select music is the select music screen. Select music. Here's all the tabs on the select music screen. Net room decorations, net room overlay. Gameplay underlay. Here's the toasty. This is how the toasty loads from your assets folder using this and this. Okay. Here's all the gameplay elements. Basically everything that you see in gameplay until death is in this one file. Evaluation decorations. Here's how everything in evaluation ends up looking the way it does. It's even more complicated than the other file I just showed you. And all this other stuff. I mean, it's really not that hard. You just Control-Shift-F if you don't know what you're looking for. And if you don't know how something works. And if you don't know what you're looking for, Control-Shift-F for a string that is remotely close to even the context of what you're looking for would help. So like, if you don't know anything about filters, bro, just this is probably a little bit much, but it gives you something. Input filter, probably not. Filter manager, interesting that it talks about skill sets when the skill sets show up here. Maybe this is what's controlling the filters. And then you start seeing, well, this is a singleton. You've got a bunch of add methods defined here. Where does this show up? Well, here's the rebirth filter, and here's the till death filter. So, problem solved. And now you think about, well, how do the filters filter all the filter the songs? Well, that is, one second. That's gonna be, it might be easier if you just search for this, which is defined right here. It's a global variable, and that means anytime you want to find out where it's used, you would look it up. In fact, we want to be more specific about it. We'll do this, and I mean, here it is. This is how songs get filtered, or the charts get filtered, and it's so obvious once you figure out how it works. I don't know. Anyways, there's one other thing you want to know is that if you're loading a folder, so like you can actually load actor a folder, or you can. Okay, let me go backwards. You can define a screen in two different ways. You can define the layers of the screen individually this way, or you can define a whole layer as a folder, and the default .lua in the folder is the root. So this file then needs to do its own loading of the other things in the folder. So let me find this scoreboard and MP scoreboard are loaded by the default Lua, and that's how they end up on the eval screen decorations. And this default Lua has nothing else special in it except for the frame and the cursor. And other things do the same. Screen gameplay is a special thing where it's just like there's a toasty, and this is loaded by the C++. But what I was saying is that you can do the same thing with load actor. If you do load actor and you point at a folder, it will load the default Lua in the folder. So what I did in Rebirth, I think I did this correctly. Yeah, okay. So what I did was, in the gameplay overlay, I loaded elements and I loaded title splash. Well, we have title splash and we have elements folder. In elements, we have the default .lua, which defines what contextually will drive gameplay based on the conditions. And then these other things in the four different possible scenarios you can be in gameplay, these will load. So if you're in regular gameplay, you get nothing. Or actually, you get this, which sets up all the elements. If you're in practice, you get the core density graph with the bookmarks and seeking. If you're in the replay, you get just the replay buttons. And if you're customizing gameplay, you get the logic that lets you control what logic that lets you control moving elements in gameplay. And then all these other things are the individual elements. I could put these into another folder, but why? You know? And there's other ways to do all this. I mean, this is just one of the solutions. When you're programming, you have infinite solutions to do things usually. It's up to your own creativity. Um, I think that's gonna be about it. I'm not really sure what else I need to go through besides explaining in very great detail about how every individual class works. I don't really know if that would be beneficial. You probably want to figure it out on your own. So, I mean, you can do 99% of the work just by seeing def.quad, def.ActorFrame, load font, def.sprite, load actor on a sprite. That's all you need. That will literally build 95% of every theme. It's up to you to place things where they have to go. And that's pretty much it. Like, we can answer all the questions you have about theming. You just have to phrase it in a way that the question that you're asking is not dumb, and hopefully whenever you're asking these questions, you're learning something, because when we get the same questions over and over from the same people, you're not learning, and then your questions stop being answered. So think about that next time you're trying to theme something. Node skins are very similar to theming in that if you don't know anything about the node skin, Ctrl-Shift-F in vscode. It will tell you a lot of things. Everything you need to know about a node skin is going to be defined in two folders, two files called Node Display and Node Skin Manager. And that's it. I mean, there's not much more to, it. So that's it. Thanks for watching.